So great. Thanks and welcome to Atlassian Enterprise Day here in New York at the Amazon office. Today we're going to spend a little bit of time educating you the insights of leveraging AWS to run mission critical applications on AWS. And also we have a customer and also Atlassian here today to present a little bit of their insight and experience working with us. This event is actually going to be broadcasted via webinar. So people in the webinar here, if you have any questions, please feel free to just type in the chat and we will answer them at the end of the presentation. Again, during the presentation, if you have any questions as well, please feel free to raise your hand, or we can leave all the questions to the end. So for today's presenters, we have Joe Tong, who is our Atlassian Channel Manager coming, Phi Wen, who is our VP of Distinguished Engineer, and also our customer, Angela Streeter from Retail Me Not, who will be presenting. Quick run on agenda, we're going to do a quick introduction. Give you a background, what is AWS, since we are in their office, so we want to do that. Also, what is Atlassian for new Atlassian customers who are not too aware of the product. And I'm going to do a deep dive into Atlassian Data Center, which is the topic of today, and how you should leverage that for mission critical applications. How to scale data center on AWS, followed by a customer example of Angela telling her about experience of running Atlassian on AWS, and we'll close it off. So to start, who is iTMethods? So iTMethods was founded in 2005 as a managed service provider, and over time we evolved, and now we're full-on AWS. So we have customers across North America, and our focus is providing cloud subscription and SaaS service offerings to our customers, including Atlassian as a service. We are an AWS Advanced Consulting partner and also a managed service provider. And beyond that, we started becoming a Atlassian solution partner last year. And our focus is that we launched Elasticity.io, which is a productized offering of managed Atlassian on AWS. Quick run through of our services here on the left, starting here, is our cloud adoption services, because we focus on helping customers maximize the value on the AWS cloud. So we offer migration services to help you rebuild, refactor, migrate different types of application onto AWS. We help customers maximize the DevOps initiatives and capabilities, CI/CD tool chains on the cloud. Help customers build cloud-native apps on AWS. And of course, the biggest trend right now is big data, machine learning. As part of our subscription projects, we offer Premier, which is our managed AWS managed service offering. A step beyond that will be our DevOps Plus, which is a managed service offering, but also helps you build your DevOps capabilities, your CI/CD tool chains. An extension of that, we have toolchain management, which is for companies who want to leverage AWS to host and integrate all your CI/CD DevOps applications. The meat of today is our Elasticity, which we're going to touch about later, is managed Atlassian on the AWS application. And Elasticity is big data SaaS. So these are just some of the companies that we work with as a background. And I'm going to pass it off to Joe Tong, who will give you a more deep dive into who Atlassian is.
Thanks, Andy. First of all, quick show of hands. How many folks are Atlassian customers and understand products? Great. So I'm speaking with a friendly crowd. In that case, I'm assuming that this picture, you live in this world somewhere. And so this is whether you're in the software development world or application lifecycle management. Our tools really are support the goals that you have to be able to achieve the business objectives in these areas. One thing I'm very cognizant of, though, is that when I meet a customer, what one customer thinks about Atlassian and the products they use may or may not be similar to what others do. As an example, I was just at the DockerCon event, and everybody there was, very close to Bamboo and Bitbucket on the release management side. Whereas other events I've done and things and customers I run into, they're all about Jira and understanding how to manage their tickets and the processes there. So understanding kind of where you are and the value you see from Atlassian can be different. So perspective is one of those things that I always like to at least draw upon. So in terms of who we are and some of our core offerings, Jira is really what we're known for. It comes in 3 kinds of flavors: software for organizations that are looking to manage software development lifecycle and that process. Service Desk, which is for any organization that runs and has internal or external services that they're trying to communicate with their with an organization around to be able to get work done. Service Desk is a great offering for that. And then Core, which is really essential to business process management or project management. In there also, and kind of as a bridge between Confluence and Jira, we have a new product, an acquisition that we did in Trello. And so if you're a Trello user, there's a lot of different use cases for, how do you manage, just even simple workflows around using Trello. And so that's an area that we're seeing a lot more discussion around. Confluence, which is a collaboration platform. If you're cognizant of Jive or other social content platforms, a lot of similarities there. It's wiki-based, kind of a knowledge-based, kind of single source of truth for your teams. As you start building processes and documentation and things like that, there needs to be a place for that to live. There's a lot of different ways that organizations manage that content today, everything from Google Docs to email and really in platforms as well. Confluence is a great multi-purpose tool that you can use for all of those different kinds of things. And then probably more of what, if you're on that CI/CD side and some of the things I think to talk about today, probably fitting into these into the dev tools of Bitbucket, SourceTree, and Bamboo, being able to manage code from the process of branching it and then pushing it back together. How are your developers interacting with that code? Who has control over it? All of that happens within those dev tools. And really the glue kind of that holds it all together is HipChat, of a tool that is a real-time messaging tool. Maybe you're using Slack and things like that. There's a lot of customers that are getting benefit from HipChat specifically because of the hooks it has into the other applications. And so being able to call HipChat to manage from there what's going on in other applications and kind of getting updates on code releases and watching that through the pipeline, all of that can be observed and managed through HipChat. So a lot of efficiencies through there. In our time as a company over the last 14 years, we worked with around, the numbers that we're saying now is like 80,000 customers. And so across every industry, wherever you are, really there's a lot of value that the organizations that we deal with, really get from the Atlassian tool set. And really a lot of that happens, it starts at a very baseline level where a customer says, hey, I want to be able to accomplish these things or manage these processes or maybe this work, and they come and find Atlassian and they start working on it, and it kind of grows and builds from there. And there's a lot more that can be gained because it was always our vision to be able to not only build great product, but also have a marketplace to be able to go to really fill out the capabilities of that tool chain. And so it's not uncommon for a customer to go in and say, I want to be able to do these other things as well. And so maybe it's building specialized tables or being able to run specialized scripts in Jira or Confluence. And so we have a marketplace that has thousands of additional applications that really bolt on to it. But so that's a little bit of who we are. Kind of, I wanted to very brief way just kind of provide an overview of Atlassian and some of the product set. So if you have any questions, please feel free to ask. And then kind of a final plug is that we just came out of a summit event in Barcelona, and one of the big things that we talked through some product releases there around some development tools and things like that. One of the big things that we released and launched in April was the new Atlassian community. And so as a customer, as partners, it's a place to go to ask questions, to engage, to get information. I know that a lot of times with Atlassian that we're still a growing company, and sometimes either kind of getting all those questions answered can be a challenge at times. And what I've found is that going to community, there's a whole lot of information that's there. So since this was something new, I wanted to definitely highlight it. Because I think there's a lot of value in the engagement of us as a company, partners like iTMethods, customers like yourselves, kind of coming together in a single place, and they really have invested quite a bit at a great centralized location. So definitely check that out. But like I said, if you have any questions, I'm happy to answer them about Atlassian, kind of where we're going and some of our products. But I'm just really here to support our partner, iTMethods, and all that they're doing to help customers get up and running and scaling out their environments, their Atlassian environments inside of AWS. And so that was that's my little overview. So thank you very much for coming.
All right, so I'll just skip that slide. My name is Phai Wan. I am the VP of Engineering at iTMethods. So I get the pleasure of sharing what I know about data center here today with you guys. But before we get started in that, how many of you here leverage Amazon for any kind of workload right now? Okay. And how many of those workloads are production workloads? Okay, great. How many of you have used Atlassian Data Center, either Jira or Confluence or Service Desk? Okay, and are those also running in AWS? Yes, some yes. Okay, great. So I guess to kind of level set everybody, I'm going to go through a quick walkthrough in terms of AWS, what clients are using it for, what kind of some of the services that are available, and then I'll talk about specific Amazon services that are leveraged to support the operation of Atlassian Data Center. So you can kind of map the Atlassian, architecture diagrams into Amazon building blocks. So when we talk about a load balancer, what does that look like in Amazon? So from an Amazon perspective, it enables businesses and developers to scale their web applications or any kind of application, not necessarily web. We should probably change that slide to include enterprises. This is no longer a startup cloud, right? It's enterprises, heavy enterprise workloads that are running here for large clients globally, not just enterprise clients, but government organizations as well, universities, federal, municipal, it doesn't matter. You're going to see clients that are leveraging AWS all around the world for production workloads. One of the biggest things with Amazon is the pace of innovation. So looking at this slide, from 2010 to 2016, Amazon has released over 1,000 features and services last year alone. So this encompasses the 90 different services they have, managed services that they have in their offering, but 1,000 features in a year, it's somebody pushing the commits and the release into production 3 times a day, right? So it's a staggering number, and you can see that number continues to grow, and it's not a linear curve. It's starting to look like a hockey stick. So the pace of innovation is going to grow even quicker. And one of the comments that we always hear is, if you as a client, as an enterprise, as a small business, if you're not innovating and keeping up with your competitors, then you're really moving backwards, right? And using and leveraging Amazon and their pace of innovation helps you move your own innovation forward and be able to compete with your own competitors in your particular market segment. From a platform perspective, this is a bit of an eye chart, right? So this encompasses the 90 different services that Amazon offers. Most people tend to start off from an Amazon perspective, jumping into EC2 or compute, right? Maybe some storage in S3, maybe RDS for databases, but there's so many more services that you can leverage and add on to your particular workload that you can take advantage of to ease your own burden in terms of your own staff having to administer certain technologies. Amazon most likely has a service that can do that and offload your staff and your team from doing that. From a benefits perspective, I just want to highlight some of these things. The biggest benefit that I see is with respect to competition. As a startup or as a small business, and you're trying to compete with the enterprises of the world, Amazon really democratizes infrastructure, right? So if I'm trying to run a Hadoop cluster or an HPC cluster that would normally have cost me hundreds of thousands of dollars to build, I can run that in Amazon for a fraction of that cost and turn it down when I don't need it. So this really allows the big players and the small players to compete against each other for any type of workload and any type of client that they're trying to to go after. Another benefit is cost, of course. Stop guessing capacity. In the traditional data center co-location, I'd have to build out capacity for the worst case scenario, right? And I'll always have some kind of a buffer in terms of the number of hosts I'm running in VMware, CPU, memory, disk. I always have a buffer in case something happens. But in Amazon, I don't necessarily need that buffer. My environment should be architected so that it can scale with my demand, up during peak times and down when business is a bit slow. So my cost will fluctuate up and down with respect to my requirements. And then lastly, in this digital world, the ability to go global in minutes, not even minutes, potentially in seconds, if you're architected well, it's phenomenal from a market-based perspective. You can reach clients globally just by clicking a few buttons within AWS or running your code against the Amazon API to provide your clients globally with the same access that somebody would have locally here. And then lastly, 1 million active customers, over 1 million active customers. If you pick up your smartphone now, I'm sure you're going to have probably 5 or 6 of these apps running on your phone right now. And these are not small players. These are enterprise apps that are used by millions of users globally. So if you've got any concerns in terms of running a production workload in AWS, just looking at the customer base that currently runs in AWS should really ease that for you. One of the biggest questions when we talk with new clients or potential clients looking at Amazon is security, right? And we always get the idea that security within the cloud, it's up there. I don't know what's going on. How do I know it's secure? So this is a responsibility that lies both on Amazon as well as on the end user itself. So it's a shared security model. Amazon manages the security of the cloud, which is everything below that line. And then you as the user, as the application designer, are managing security of your application. So there's really no difference in terms of securing your application in AWS or in a traditional co-location, right? You're still going to write your code in a manner that is secure. You're still going to leverage encryption just like you would in a co-location. You would still configure to use encryption in transit between your applications. So all those things still apply, and those things are part of your responsibility as the application designer. The underlying fundamental architecture is managed by Amazon, and security of the cloud will be their responsibility. And that's also no different than your current data center provider who's managing the underlying hosts for you, right? They're the ones who are managing security and access to those hosts, what changes happen on those hosts. So it's very similar in terms of the shared security model. If you were to go and look up AWS in terms of its compliance and security compliance, they're probably the top in terms of the number of certificates and compliance designations across all providers that you can find out there globally. And just wrapping up on the Amazon side, so Amazon has 16 regions today, and a region is basically a collection of data centers. So in the Amazon terminology, a data center is called an availability zone. And within a region, you're going to have multiple availability zones. So each availability zone is actually a discrete set of servers, basically a data center that is built and deployed in different floodplains from the other data centers in that same AZ. They have different power connections. They've got different internet connections, different network connections. So the AZs are really completely independent of each other. However, you can leverage multiple AZs within a region to give yourself high availability. And we'll talk about that when we talk about data center directly as it relates to Atlassian. So jumping into Atlassian data center, if you're running Atlassian, if you're running server, you're going to have issues from time to time, whether it's an outage, whether I run out of disk space, whether a host fails. Because I'm running on a single node, I'm going to have an outage. And it's estimated even a 30-minute outage could cost an organization around $25,000. And this is probably on the conservative side. If I've got tens of thousands of users using the Atlassian application and it's unavailable for 30 minutes, the productivity of my team goes down dramatically. And that's going to be a major cost, right? And this is not just an outage. Even when I have to do maintenance of the environment, you know, I'm taking the system down to do my backups and then do my upgrades and then bring it back online. That to me is still an outage, right? It's a controlled and managed outage, but an outage nonetheless where the productivity of my team decreases. And that's where data center is going to help manage some of those outages for you. How many here have or actually do these types of maintenance right now? Are you the actual Jira or sysadmin that manages upgrades? A few lucky souls, right? So we've all been there, you know, working after hours into the evenings, whenever your developers aren't working, to be able to take a system down and then bring it back up, and hopefully, you know, everything kind of is working. So data center is going to help to alleviate some of those issues, those overnight upgrades that you need to do. So there are 4 data center products that are available now. So software, Jira Software, Bitbucket, Confluence, Service Desk, and then HipChat and Crowd are available. I think you have to sign up for a beta. You can go online and sign up for those data center betas as well right now. So as Joe had already mentioned, there's different models in terms of how you can deploy Atlassian. So Atlassian Cloud, where it's fully managed by Atlassian. Server, where you're deploying Jira Server, Confluence Server on your own host. And then Data Center, which is also deploying the application on your own host, but not just one host, a set of hosts. Data Center looks to address, you know, 4 primary issues, right? High availability, performance at scale, instant scalability, and disaster recovery. So we're going to go into each one of these, and then we'll look at the actual deployment in AWS. So high availability, it's the term itself, it's really making sure the system is available to your end users as much as possible, right? So increasing the availability of the environment. So this is done by clustering, right? So multiple nodes will run active, and I will hit each one of the nodes depending on my load balancer and which node I get directed to from an actual task perspective. Distributed load is with my load balancer sitting in front of all my nodes. My load balancer is going to be smart enough to distribute load to specific nodes based on a host of different parameters. So whether it's CPU or memory or a number of connections, your load balancer is going to be aware and send, you know, new connections to a different host. And then of course redundancy, right? Once I have an active cluster, if I lose a node, not a big deal. The system should be able to self-heal and bring up another node to replace it, right? And when we look at Amazon and the ability of auto-scaling, great, it can recover from a single node failure, but it can also scale up based on load. It can also scale down based on load, right? So you can see the flexibility that you gain with running this in AWS. Performance at scale. You know, some of the pain points with running server is that during peak times, things kind of slow down, potentially, right? If I'm running a certain size server and I get an uptick in number of users, or I'm running something heavy against it, things slow down. If I ever have to re-index, things slow down, right? And users get affected in terms of that. So being able to scale without that slowdown is what Data Center is offering here. One of the other issues that we always see is, well, I've got a lot of API calls, right? And I'm hitting my Jira server, you know, all the time with these API calls, and whenever that happens, things slow down. Is there a way to direct API calls to a specific node in my Data Center cluster, right? So that my users can hit one node, my API calls can hit another node, and my users are not impacted. And yes, there is a way to do that, and we'll talk about that in one of the slides coming up. So performance at scale, concurrent user capacity. And if you've looked at the Atlassian white papers in terms of some of their performance and load testing, you'll see that the concurrent user capacity is more or less linear. You know, if I've got a node that is configured to support 1,000 users and I add another node, it scales linearly. So I can have 2,000 users now running on 2 nodes. Add another node, I'm at 3,000 users. It's very linear in terms of concurrent user capacity. Application resilience. So as I increase my number of users, I want the performance for those users to be the same, right? If I'm adding more users, why should things slow down, right? So the application resilience and adding multiple nodes maintains that same application level throughput for all your users, right? And coupling these two together, concurrent user capacity and resilience, is what gives you the outcome, which is quality of service for your end users. You know, if all I can do is add concurrent users, but my throughput drops, then the quality of service is bad, right? If I can keep my throughput high by dropping the number of concurrent users I have, quality of service is bad. So I actually need to maintain both of these at the same time, concurrent user capacity and application resilience, and being able to scale both of those at the same time makes for happy users. Then instability, of course, when there's issues, when I need to retire a node, I can bring up another node. When my throughput increases or the number of users increases and demand increases, I should be able to scale up another node. Now, I can probably do this right now in VMware if I'm running in a VMware environment by adding another node, right? Going into vSphere and adding a node and adding it to the cluster. Or if I have that coded through the API, I can probably do that through an API call as well. But imagine if you didn't have to do that, right? Imagine if you can just set it and say, okay, once my servers hit 60% CPU, add another node for me, right? Once my servers, come down to 20% CPU, remove one of the nodes for me, right? And try to maintain a level of nodes that would keep your users happy while also keeping your business happy by maintaining costs and controlling costs. Rapid reindexing. It's probably one of the largest issues from a performance perspective. Whenever the index gets out of whack with the database, I have to reindex. Either I lock the system, so I do a reindex and that's faster, or I do a background reindex, which kind of slows the system down. So in this case, you can actually have one of the nodes do the reindex, right? Take that, if you're running it behind a load balancer, take it out of the load balancer, reindex on that node, add it back to the cluster, and it will then copy the index to all your other nodes. So while it's doing that reindexing, no users are actually hitting that particular node, right? So that your user performance and throughput is consistent. You can also do that automatically if you're using a layer 7 application type load balancer that's aware of a particular path. So Atlassian publishes the /status for a health check. So if you're monitoring that health check and you put a node into reindex mode, it switches to maintenance mode and that health check will fail. The load balancer will remove that node out of the cluster while it's reindexing, and then it'll re-add it back into the cluster once it's done automatically. So there's definitely benefits, even if you're only looking for reindexing. This is one of the main benefits here that I can see, just to reduce the amount of time that it takes to reindex and reduce the impact on your users when that happens. Predictable costs. Regardless of the number of nodes that you run, the cost for Atlassian is still tied to the user license. So I could have 1,000 users running on 2 nodes or on 100 nodes. The cost is still the same from an Atlassian perspective. Of course, you got to pay for the actual usage of the hardware from an Amazon perspective, but auto-scaling will help you control those costs. And then lastly, disaster recovery. No different than how you kind of run Jira ServerNow or Confluence and what your DR strategy is. Typically, you're going to have another site somewhere and you're going to replicate the database and all your storage information to the other location. And then when there's a failure, you're going to make that database master and you're going to turn on a new node. And we'll look at how you can do this in AWS relatively quickly and relatively seamlessly. So getting into each of the applications here. So from an Amazon and Atlassian support perspective, these are the 4 Atlassian data center products that are officially supported on AWS right now. The other ones will be coming. So I'm going to walk through some of the Amazon services that you're going to need to be aware of when you want to run data center on AWS. So the first thing is the load balancer, right? So it's an elastic load balancer, and Amazon actually has two kinds of load balancers right now. So there's a classic load balancer, which is basically port forwarding, 80, 443, 8080. You go from one port to another port. And they also have an application load balancer, which we will take advantage of when we're doing Confluence for sure, or if we want to redirect specific calls to specific nodes instead of just blanket all the nodes in a round-robin fashion. CloudWatch in AWS, this is a monitoring system that's part of Amazon, and basically all the services that Amazon has feeds into CloudWatch. So it can monitor metrics, CPU, disk utilization, I/O, memory, and so on and so forth. And if it's not a built-in metric, you can always customize and create your own metrics that feed into CloudWatch as well. And then lastly, auto scaling. So auto scaling group is basically the ability to scale up and down the number of nodes I have in a particular cluster. Right, and the boxes in the middle are my compute nodes. So those are the ones that are actually running the application. So the load balancer will distribute my requests to the two nodes, so the nodes that are part of my auto scaling group. The load balancer also feeds information to CloudWatch. So latency metrics, how long is it taking for the backend node to respond to my call? It's also feeding utilization from the instances over to CloudWatch. And with that information, I can create a policy that will say scale up or scale down. So if CPU hits 60%, then scale up, right? CloudWatch will then let the auto scaling group know that it's time to scale up because I hit a particular threshold. I hit 60%, add another node, or add two nodes, depending on how aggressive I want to be in my scaling. Auto scaling will then add another node, and once that node fires up, auto scaling is monitoring its health. And once it becomes healthy, auto scaling tells the load balancer to add it to the pool. And then the load balancer will then start sending traffic to that particular node. Now I have 3 nodes, and this process can carry on in terms of growing and adding the number of nodes to the environment. It can also scale down. So CPU hits 20% for a period of 5 minutes. I think I'm pretty stable now. I'm going to take a node out of the system. CloudWatch is going to tell auto scaling to retire a node. And then the same process happens in the reverse. Auto scaling will take a node out. The load balancer will allow the connections to drain off the existing node before it terminates that node. The other type of load balancer was the application load balancer. And this is a bit more involved, and it's probably similar to some of the more traditional on-premise load balancers that you would use, like an F5, where you have a bit more flexibility in terms of some of the rule sets that you can do. So you can create listeners in the application load balancer. So whenever I get a request for a particular host header, or if I have a URI that has /API, let's say, then direct the traffic to this set. Right? And then within that set of nodes, I have targets, and that target group is going to be part of my auto scaling group. So that target's going to scale up and down as well. Right? I can also have a separate listener. So for example, here API also have Synchrony for Confluence. So Synchrony is going to have its own application load balancer. So when you're editing in Confluence, it is going to update the right nodes. And all of these nodes, although they're drawn in separate boxes, they're all part of a single Jira data center cluster. They're just performing different functions by directing specific types of traffic to it. Right? And I can also have nodes that straddle or sit in between different groups. So I don't have to have, 3 nodes in each group. I can share resources to also maintain and control costs. So those are the application load balancer, the classic load balancer, as well as the auto scaling and CloudWatch. Now, from a security perspective, everything is going to be deployed inside a VPC. So a VPC is a virtual private cloud. It's an isolated part of the Amazon network that allows you to maintain control of everything inside that particular VPC from a networking and security perspective. If I had to liken that to like your traditional network, I would say it's like a private VLAN with a VRF associated to it, where I can isolate a particular segment of the network for a particular workload. So that's the VPC. And you would deploy your environment inside this VPC, regardless of what kind of environment or what kind of workload you're looking to deploy. There's actually no option now, because all the new accounts that you create are only VPC. You cannot deploy it outside of a VPC anymore. The other service is Amazon RDS, Relational Database Service. So this is a managed database service that Amazon offers, and it has the following different types of databases that you can use: Aurora, MySQL, Postgres. If we're talking specifically about Atlassian and in a Linux environment, then we're probably looking at MySQL or Postgres. But basically, from an RDS perspective, it reduces the management tasks required to maintain your database. So upgrades, minor upgrades, Amazon could do that. Failing over from the master node to the slave node, Amazon could take care of that. Backups, Amazon will take care of that. Restoring snapshots, Amazon will take care of that. So the benefits that you have with RDS, I think, outweigh the team members that you're going to need to be able to manage your database. All right. So this is the database. This is the solution that is used in terms of the Atlassian data center on AWS. Then lastly, there's a requirement for a shared storage for a data center. So some kind of NFS shared file system. So this is where EFS comes into play. So it's Amazon's NFS, Elastic File System, and it basically can scale up to petabytes. The beauty of EFS is I never have to increase the size of the disk. It would just grow, right? Whereas right now, if I'm running out of disk on my shelf, got to add a new shelf, got to add new drives, and add that into the system. Right here, I create the mount, and I start throwing data at it, and it will grow and scale with you without you having to do anything else beyond the initial setup. Right, and from a size perspective, I think the maximum size of any file that you can store in EFS is 52 terabytes. So it's a pretty big file in terms of scale of this environment. So EFS will serve as the underlying shared storage for Atlassian data center inside AWS. If you've looked at the Atlassian documentation, you'll see this diagram fairly often, and this is a server diagram, so load balancer, application node, and a master database. Right. So if we look at high availability, aside from just the application node itself, there's some other components that I need to make highly available as well. Right. So first thing I would do is add another load balancer. Right. If the load balancer fails, the system needs to be up. Second thing I would do is add a slave database or a standby database. Right. And that's about as far as you can take it from a Jira server or Confluence server deployment perspective, because I can still only have one application node. Right? Of course, if I'm running VMware, I could do vMotion. If it fails, I can do FT. I can do vCloud, vRealize, and get the system back up and running quickly, but not have the redundancy. So that's where data center comes in. So being able to add multiple nodes, and then the requirement of shared storage. So this is the diagram you would see for Atlassian Data Center if you go to their page. So we're going to map this now to AWS. So replace the load balancers with an Elastic load balancer. Replace the application nodes with EC2. Right? Drop EC2 inside a scaling group. That allows me to add multiple nodes. Replace the databases with RDS. And replace the shared storage with EFS. Right? So pretty straightforward from a building blocks perspective. So what about high availability? So I have all this stuff running, but what if that data center goes down, right? I lose everything. right? So this is where the notion of availability zones comes into play. So I can take everything that I have here and split them across 2 availability zones, right? And if you remember from before, an availability zone is a discrete data center that Amazon operates. So just by doing that, I now have HA across 2 data centers. A failure of one data center should not impact my application, right? And the beauty of this is Amazon takes care of that for you, right? I can deploy my load balancers in multiple AZs by checking a box, right? I can deploy my RDS in multi-AZs by checking a box, right? My EC2 instances are deployed in multiple AZs, and the auto-scaling group load balancers or creates my nodes across my AZs by checking a box, right? So I don't have to worry about the underlying architecture. I just have to tell Amazon to use it, right? So from a, if high availability is not enough, multiple data centers within the same geographic region, we look at disaster recovery. So great, I'm running everything out on the East Coast, but what if there's something catastrophic that takes all the data centers down on the East Coast? I need to move everything to the West Coast. So this is where you would stand up another environment over out on the West Coast or here at Region 2. And you would use tools such as IAC or infrastructure as code to build that environment for you, right? You would use IAC or bootstrapping or snapshots to copy your nodes over. You would do backup or replication of EFS and replication of your database. The beauty of this is that aside from base and the EFS storage, the other components do not need to be running, right? They can be instantiated when there is an issue. So in the traditional disaster recovery where I have VMware and I'm using SRM to another data center, I need a target environment for SRM to work in. I need hardware and capacity to be running there all the time. In this case, I can run a slimmed down RDS database and copy my EFS storage over, and all I'm doing is backup and snapshots over from one region to another. When there's a failure of the primary region, that's when I turn things on, and that's when I start getting charged for it. So I don't need to have a target environment that's up and running like I do in the traditional data center world. Then lastly, from a performance at scale, and we talked a little bit about this before. So if I've got Jira and its heavy usage is API, and that always impacts my user base, especially if I'm running server, with the application load balancer, I can direct API traffic to a set of nodes. I can direct regular user traffic to a set of nodes, independent of each other, so my API traffic does not impact the performance of my end users. Another potential benefit is administration and power users. So what if I want to lock out administrative type functions from anybody outside my organization, right? So jira.itmethods.com/admin. Whenever I see a /admin, I want to block that from outside, but I want to allow it from inside. So I can create a private load balancer that's tied to my corporate network, and anything /admin goes to a set of nodes. So in this way, I can also secure the environment from administrative changes when I'm not inside the corporate environment. So there's a lot of benefits here that you can start to see and start to realize once you're running multiple nodes, and you have the ability to direct certain types of traffic to certain sets of nodes. So then lastly, this slide is really just a overall comparison slide looking at the data center environment from an Atlassian architecture documentation perspective, and then mapping that over to AWS and what some of the components you would need to run data center on AWS. I will be around as well after the session for questions. If you've got questions on the webinar, please ask them through the chat as well. But at this time, I'd like to invite up Angela from Retail Me Not, who's one of our clients that's leveraging the Atlassian platform on AWS.
Hi. I'm Angela Streeter. I'm the Senior Systems Administrator at Retail Me Not, and we are on our journey to achieve what Phi just showed you with data center. We are not all the way there yet, but we are in the process. And just a little background, if you don't know what Retail Me Not is, we are a savings destination for consumers, and we help, let me flip this over to the, we help consumers and retailers connect with digital coupons, gift cards, discount codes, savings, that kind of thing. We are built on the cloud. We have a lot of different types of applications. We have the traditional desktop experience. We have mobile. We have in-store offers, all of that kind of stuff. So we are fully leveraging AWS currently for our own development and engineering. Just a little bit about our company. Obviously, we reach a lot of users. We have been fully utilizing AWS for a long time. So a little bit about our Jira instance. So as the system administrator at Retail Me Not, my job is a lot different than it used to be. So I've been a system administrator for many years. I did traditional server management. We still have what I call legacy hardware in our environment. We have a very small data center in-house in our offices, and we leverage cloud as much as possible in everything, SaaS, all over the place, right? When we were a smaller company, and we're very agile, right? So our engineering and development teams, they want to innovate and use the latest and greatest all the time. So they bring in some application that they want to use. In this case, for a while, our engineering and development teams primarily used Jira and Bitbucket, right? They used it for their development purposes, and they were the primary users. They managed it. They were the admins for these systems, and they made decisions based on that. And originally, we had much smaller instances. They need for it grew a little bit, right? And over time, we realized that this has now become mission critical to our business. It needs to have 24/7 access, right? Those Phi pointed out these server maintenances that need to happen on physical machines, just upgrades to Jira, Confluence, those types of things. So our original instances were physical machines until very recently in the last few months. We had 3 physical servers in a managed hosting provider's data center, right? And Jira and Confluence resided on the same instance. We had a database instance, and then we had a single one for Bitbucket. As you can imagine, as the users grow, now we don't just have engineering and development using this. Now we have business teams using it. We added in service desk. And now we have support teams across the world that are using this for their various purposes, right? And we all have different uses for it, including the IT team. So the IT team also utilizes service desk. So we realized that quickly this was becoming a problem. So one of the things that was typical, Jira and Confluence running on the same instance, there could be a lot of noise. The ability to separate out that traffic, we have many servers in AWS that are contacting Bitbucket and Jira all day long, 24/7, using the API, right? The ability to separate that traffic would be great for us. We're not there yet, but we are on the road to getting there. It was also really beneficial to us that Elasticity is running in AWS because we already run there. We are familiar with the tool sets. We're familiar with how the automation works and all of that kind of stuff. So I kind of reiterated it there. We just realized very quickly that we needed this 24/7 accessibility. We ran into many issues along the way. Our previous provider was a typical hosting environment, and they only provided ticket support, which wasn't great for us. If there was a problem with Jira or Confluence, they often did not know about it at all until we put a ticket in. We didn't have a way to reach out to them in an emergency. We did a lot of the management ourselves. We managed all the licenses. We have a lot of admins still and power users in Jira. This can cause a lot of problems if anybody that's familiar with Jira here knows. And we're working towards reducing that number down and having, in my eyes, a partner and support team with iTMethods and Elasticity is getting us further down that road. And hopefully in the near future, my work on these will be a lot less, because in the past, whenever there was a problem, I get the call at, midnight on Friday night or Saturday AM. And then I have to troubleshoot the issue myself. I have to get Atlassian support involved. All of these things would fall on our IT team. And as our company, and probably yours, our IT team is already stretched thin on all the other things that we have to manage and do. So we were looking for another solution, and we looked at several different options, and we picked iTMethods for a variety of reasons, many of which I've already mentioned. The 24/7 support was vital to us. You're going to flip. I'm sorry, I'm not flipping the slides. So our old hosting vendor, they did not do proactive support. They did not monitor the instances for us. They did not even do server maintenances and that kind of thing. Oh, sorry. I don't know all the transitions, sorry. They did not do these things. We did not have phone support, and they would not interact with Atlassian for us. So if there was a problem with the instance, we didn't know what it was, maybe it's a problem in the database, we would have to reach out to Atlassian, and then we would have to be the go-between between the two and try to resolve the problem. And I will tell you, in some instances, this often took days, if not weeks, to resolve. So, as we were looking for the solutions, top of my mind was 24/7 support. The auto backup and recovery, that was great. We did have backups with the previous provider, but they were traditional server backups. They went to offsite, but because these are physical machines and they were not utilizing the type of technology that we have in cloud now, this would often take many, many hours, and for a global company that's 24/7, this caused impact many times, especially for our European users, so we try to pick a backup time to start, and then it's really overlapping, right? And we do have 24/7 things happening. Our teams leverage a lot of automation in the API. They love integrations and add-ons. Scripts, we have figured out that we utilize the mail handlers quite a bit, to the point where we also use Google for mail, and they have rate limiting. So we, as a solution, are using AWS's mail to funnel that traffic over to Google without hitting that rate limit. So, and then also it was very key to us that they are Atlassian experts. We no longer have to be the go-between. They will work with both AWS and Atlassian for us. Since we have moved over, which was very recent, we had a few minor issues, but as soon as we figured out there was an issue, you know, like somebody at the office notices there's lag time or they can't reach the instance, we are on the phone, we call them, we get them on the phone immediately, and not only have they already figured out that something's happening because they're monitoring it, but they're already working on it, and they've been great. So also in that instance, we had an issue with one of the servers, and we're not sure what it is right at the moment, but they have put in place active measures to monitor the instance and debug and troubleshoot along the way. And so when it recurs again, we can find out like what is the cause, right? So we're very happy that we have iTMethods as our support team for this product.
Thanks so much.
I think we are pretty much at the end of that. Yeah, and it was also a bonus that they do offer license management. Another thing that was very important to us is flexibility. So for example, I mentioned that we are utilizing Amazon's mail service for our mail handlers. We could have had that happen in the account where the instances reside with iTMethods, but we chose to use one of our own accounts for that traffic instead. And we appreciate that because they did offer that as flexible, right? They could either do it there or we can control it in our instances. So we do like that ability to decide how we want to handle it. So, and I'll be available if anybody has any questions. I think I'm pretty much done on that. Yeah, I think we're here, right? Thanks, Andy.
So wrapping up to conclusion here. So this is just a high-level screenshot. Again, Velocity is meant to be the managed Atlassian platform for AWS. And like Fi said, we support server and data center applications. So it's meant to be a fully managed enterprise solution. Some of the features highlighted again, it's the maintenance and schedule upgrades that the customers really appreciate, and the fact how our platform supports most server and data center add-ons. It's secure and compliance by the Amazon AWS standard. So if you have any questions at the end of the presentation, feel free to come reach out to one of us, and we're happy to help answer those questions. Some of the next steps, again, would be we're available right after. And if any of you would like to learn more about service or have a custom quote, here's the link to in order to get one. And again, feel free to come reach out to me, and happy to discuss more details after. And again, upgrade to the Atlassian data set if you haven't already. There should be no reason you shouldn't. And deploy and migrate to Velocity if this fits your needs.